My name is Benard Bett. I work here at the International Livestock Research Institute as a veterinary epidemiologist. I've been working here for the last 10 years, focusing mainly on zoonotic diseases. So these are diseases which are shared between livestock and humans, or those which comes about when we do intensive agricultural farming, maybe through exposure to agrochemicals, or things which come with irrigated farming where you have mosquitoes coming to transmit things like malaria and other vector-borne diseases. Another component of this work looks at antimicrobial resistance. That's when we have intensive use of drugs, either in animals for treating diseases. For the last 5 years, mainly, we have been working on things like Rift Valley fever, which occurs following periods of heavy rainfall. So when there's heavy rainfall and flooding, we get high populations of mosquitoes, which then amplifies the transmission of the virus which causes the disease. So the disease affects livestock. It causes abortions, mortalities or deaths in the large populations in livestock. In humans, it causes a severe febrile disease, which can cause death. But in many cases in humans, the disease doesn't really show any signs. So we usually assume up to 80% of the cases go unreported because people don't realize they have the disease. But it's only in the small proportion of around 20% where the disease develops into a severe hemorrhagic disease. Yeah, so usually when somebody gets the disease, you get fever, sometimes you get vomiting or abdominal pains or muscle pains, and usually it leads to yellowing of the eyes because it affects the liver, and so you get what we call in scientific terms jaundice. So those are the key signs in humans. But in livestock, the main sign would be abortion. So you get many animals aborting at the same time in a given population. Currently, the main control method is vaccinating livestock. So we don't really have a vaccine for humans. So for humans, usually you go to hospital, you get symptomatic treatment. That means you are given, doctors would manage the febrile condition through various ways. So the main method which we use now is vaccinating livestock. But also we control mosquitoes through insecticides, but it's better to vaccinate than using insecticides when the disease is already there. Rift Valley fever is one of the vector-borne diseases, so we have others which we are working with here at ILRI, ranging from things like chikungunya, which is mainly a human-borne infection. We have other tick-borne diseases, which includes things like Q fever. Those are also zoonotic diseases which are shared between livestock and humans. So one of these methods which we use is educating the public to understand or to recognize these diseases. So that will be the first point at which they can participate in surveillance. So notifying authorities whenever they see any initial cases of these diseases. But we really recommend that they vaccinate their animals when there is no disease, during what we call outside the main epidemic periods. That means if you vaccinate animals, by the time conditions are ripe for a disease to occur, most of the animals will be immune, and so there is no outbreak occurring. Our project mainly helps in building capacity within either interventions, mainly helping the governments who are responsible for controlling these diseases to get new technologies for controlling the disease like vaccines, or new techniques or strategies for applying those vaccines. So you can have a vaccine, but if you don't have a good strategy, you may not really achieve what you are aiming to do. So one of our key focus is to design better ways of administering the vaccines and timing of the vaccination program. so that you can reap more benefits from applying the vaccines. And also another thing we keep developing is risk mapping to help authorities know areas which they should be focusing for either information dissemination or deployment of vaccines. So we have risk map for various countries which these diseases are occurring. The other major help or the major contribution we give is contingency planning, where we develop tools which guide authorities on when to do what activity in which place. So it's mainly decision support framework for interventions. We work in multiple countries. So in East Africa, we have been working in Uganda, Tanzania, Kenya, and in the coming few days, we are expanding our work to South Sudan. But in other places, we have work in Southeast Asia, focusing on vector-borne diseases. And in those places, we're also developing risk maps for diseases like dengue, chikungunya, and Japanese encephalitis, which are also transmitted by mosquitoes. The main challenge is the quality of funding we get really limits some of the work that we do, because most of the funding agencies are coming from developed countries and they are very much focused on problems which they identify with. So these disease challenges could be those diseases which are likely to be transmitted to their countries. But when you come to our regions here, there are many other diseases which have been neglected. And because it's a localized problem, and so we don't really get funding for those diseases. So an example is the one I told you earlier on about tsetse flies. Currently, it's not receiving much attention because it's a localized problem, which really affects most of our animals, and so it goes on unaddressed. For our African countries, we shouldn't really be relying for everything. We shouldn't be relying on the international funding. They should be developing their own local initiatives for funding endemic problems. So for some countries, for example, we have so many regional economic blocks in each of the sectors of the continent, which they should be setting aside funding to support diseases which are always there but don't receive attention from international donors. We've been concerning ourselves with we call them dynamic drivers of disease, which are things like climate change or increase in population or land use change. So these are driving changes in our ecology, and that makes some of the diseases to become more prevalent. And we should be addressing these things because, for example, the more the population rises, the more people uses natural ecosystems like forests or more irrigation or things which will enable them to get more food to feed their population. And these things, all of them work together to increase risks of some of the diseases. I think livestock research is really exciting sector which can open up. As a scientist, it gives you major challenges to think of all the multiple things which come into play, right from raising animals to managing diseases to managing environments. And so it's one of the things which, as a young scientist, you can really get so much to do. So livestock they really play a big role in boosting our livelihoods, and if we want to make them more productive, then we should look at using the current technologies for managing diseases, and we shouldn't wait for an outbreak to occur. We should be applying these control methods all the time.